this video, we're going to dive deeper into LINQ to objects, both the method syntax and the query syntax shortcuts. And we're going to be talking about projection, which is a LINQ term that is basically the shaping or the molding of data that's returned from a LINQ query to include just the stuff you need as opposed to retrieving every field of the object. So you can use this in a couple of ways. First of all, you can use it to convert the data from one type to another. So you can copy the value of a property in type A to a property in type B. The other way to use it is to flatten the data from this intricate hierarchy into a non-hierarchical format. So the new type could be something that's part of the framework, a type that you created, a custom class, or an anonymous type, as we've seen earlier today. So we're going to start with simply selecting an entire sequence from a collection, and then we're going to start selecting single fields, or rather new instances of a name type. And finally then, we're going to select data into anonymous types. So we're going to start by using the query syntax, and then we'll show how to do the exact same sorts of operations using the method syntax. So you can choose which style that you prefer. Alright, so for the most part, there would be a lot of typing. It's easier for me to copy and paste from an existing example and just to show you what I've done here. Alright, so this is the most simple case that we can come up with. First of all, let me start off by saying that this is the setup orders method that we've used throughout these examples. Setup orders creates a series of orders. Each order owns one or more order items. Okay, so let's close that up because we've seen this before. Here's the order class, and an order class also can contain, as you can see here, a list of order items, and it will also have a billing address and a shipping address. I'm not sure if we're going to use those for this example, but they're there if we need them. Alright, so it's as simple as that. We just have this hierarchy of orders with order items and addresses that are associated with those orders. Okay, so in this simple case, all we're going to do is from O, an order list, select O. So just give me every single order that's currently contained in order list that we got when we set up the orders in our setup orders method. Then we're just going to print out each one to the console window. Okay, so this is a very simple, easy way to start off. Okay, looks like we have 4 orders. Great. Okay, so now, what if we only want to project out the order dates and not the entire order object? Let's do that. Let's comment this. And paste in some more code. Now look at the difference this time. Here, I'm still selecting from O and order list, but this time I'm only selecting O.orderDate. So give me back every order date for every order that's in our order list, and then I want to print that to screen. Now for every O, notice that O represents what? Well, it's going to be basically a enumerable, as you see here, of date times. So already the IDE is able to establish what the data type is going to be that's returned back in our orders variable, even though we use the var. Okay, so let's go ahead and run the application, and now we just see the order dates. Great. Alright, so let's extend this example a little bit further. What if I need more than just the order date property, but I don't want every single property of order to be pulled back? Well, we can do this. Okay, so here we go, and look at this is an interesting syntax. Before, if we only need one value, we can directly select it. But if we need more than one value, we're going to have to create a new anonymous type. So I'm selecting into, or I'm projecting a new anonymous type that'll contain 2 fields of information, an order date and an order ID. And again, we're selecting them from our order list, and then we'll print both of those values, the order date and the ID, in a console window. Alright, so this syntax shouldn't be strange to you. It's just interesting that we're able to use it in the context of a select statement to project out a new anonymous type. Okay, and so we're going to do a lot of that kind of thing. In fact, I would bet as you get deeper into LINQ, you'll be doing this all the time. I know I do. And I didn't at first, and it took some time to wrap my head around it and really understand the value of it. But you know, it definitely is something that I've come to rely on. So now let's do this. I think it's always a valuable exercise to understand what type is being pulled back. So let's just do that really quick. Now I'm using some method syntax here, but all I'm really trying to do is just grab the first item and just get the type of that item. Okay, so let's run the application. And you can see the type is anonymous type prime2, and it has as fields a date time and a system.in32, just as we would expect from seeing its definition defined here in our new order date and order ID. Okay, awesome. Okay, so this seemed to work for anonymous types, but what if we want to select data into a named type? And so what we want to do is show an example of how to both flatten and convert our data from the order object into a new data type. So let me do this. I'm going to drop down here to the very bottom. I'm going to create a simple class definition called order summary. And I'm just going to do two values here. We're going to do an order date. So date time. Whoops. Order date. And then order ID. Okay, so now we have a new class called order summary, and it just has two values. And what we want to do is project data into that class. Here we were able to create an anonymous type. That's great, but what if we want to project into a named type? How do we do that? Let's take a look at this example here. Okay, so you can see I have var order summaries equals from O in order list select new, and then I give the name of the type I want to select into, order summary, and then also you can see here that I've got property equals the value, property equals value. Then I'm just going to loop through. I could use var here, but I wanted to prove the point that this was indeed an order summary. So for every OS in order summaries, then print those out to screen. Let's run it. Okay, so that seems to work. Again, previously anonymous type, now name type. And that is the value of doing that. Okay, so let's do this really quick. As a final example of the query syntax, let's take a look at how you can even flatten not into other types, but into completely other formats. Now, we haven't talked about XML, but if you're already familiar with it, this example shouldn't be all that difficult for you to understand. All right, so let's make sure that we have a using system.xml.link namespace declared. And what we want to do is project our order into a very specific order format. And here I'm grabbing the order and creating an attribute of order called order date, and then another attribute of order called total items, where I sum up the number of items that are within the order. So this is a pretty complex projection. And then I'm going to print that entire XML document that I created, that I projected onto the console window. So let's run it and see what happens here. All right, so you can see I have an orders collection that has a number of individual orders. As a property of each order element, it has a series of attributes, the order date, and the total items in the order. So that's pretty neat. So hopefully you can see now why projection is such a big deal. It's an advanced sort of mechanism that allows you to only grab out the things you need and to flatten or to convert or to return in an anonymous type or a name type. It gives you a lot of functionality by using the projection, the select statement. One more advanced example before we continue on. How do you flatten out a list of order items across all orders? So you don't want the hierarchy anymore. You just want the individual order items. Let's go ahead and take a look at this example. For O in order list, from OI in O.order items, select OI. So even though every individual order item is associated with an order, here we're able to grab out by doing a join between those two lists of objects. So for every O in order list, find me every order item associated with each order, and then just grab only the order item. And then let's print every single order item, regardless of the order it's associated with, to the console window. Awesome. All right, again, projection, extremely powerful, limited probably only by your imagination. All right, so that's the query syntax. Let's show the equivalent of these examples using the method syntax. All right, we're going to go back through these, but at a little quicker pace. Hopefully they'll make sense. All right, so in this case, we did var orders equal order list dot select. So just give me, given an order, return me every order. Okay, and then we're going to roll through every order and print out its order date. Okay, now like we showed in the previous video, we can shorten up this. I left it on a couple of lines, but we can do it all pretty much on one line of code by doing this. Whoops, not that. I just did that. Let's do this instead. All right, for each O in order list dot select, given O, return O. So for every item in our order list, loop through and print out the order date to the console window. Okay, works. Great. Again, method syntax, very compact, not entirely, friendly on the eye as always, but definitely can be abbreviated easily. So what if we only wanted the order dates? Well, given O, return to me the order date from every O that's passed in. Not the entire object, just the order date. And then roll through those in a console window. Okay? Hopefully that made sense. Just selecting out, using the lambda expression, only the part that we needed. And for the sake of showing how we can shorten that up, one line of code. Again, only one line. I can reduce this down like we showed in one of the previous videos. So for each var O in order list dot select, given O, return the order date, print out the order date using a short date string conversion. Awesome. One line of code. Okay, so what if we need just the order date property? We don't need every property. Well, we would do something like this. And here again, the same sort of syntax that we saw earlier using the query syntax, now we're using it here in the method syntax. We're still projecting into a new anonymous type. Why is it anonymous? It doesn't have a name defined right there. And so here we go. Order date and order ID, and then we're going to roll through each one. Okay, we won't show the flattened form for that, the shortened form. I'll let you use your imagination, try it yourself. Let's go ahead and just comment those out. Next up, let's take a look at an example of flattening and converting. Remember this example from a little bit earlier? Here we're projecting into a named type, the order summary, and we're setting the order date equals to whatever is passed in. Given O, put the order date for O in a property called order date for a new instance of my name type order summary. Do the same thing for order ID, and then loop through all those and print them out to the console window. Awesome. Let's comment those out. Moving on. Remember we looked at that extreme example of projection? Remember that? Here we use the query syntax to create a new instance of X element. which contained additional instances of X element. Let's do that all using the method syntax to project out a new hierarchy. And so I would do it like this. And admittedly, this might be one case where the method syntax really is more difficult to understand than the query syntax. So we're creating a new instance of X element, passing in the name for the element and its values. And inside of the order, we're going to, actually, I think this should be orders. I think I've already got this should be orders, I believe. There we go. That'll look better if we do it that way. Order list.select, given O, create a new X element of order, and inside of that, create a new attribute called order date and a new attribute called total items, which, given a it's able to use a lambda expression to grab the sum for all the order items in a given order. Okay, again, pretty complicated, and I'm running through this fast, but just really to demonstrate how valuable that is in creating that sort of thing. Okay, and then finally, so we want to select every single order item regardless of the order that it's associated with. And so here in this case, we're able to do, let's grab this and just drag that up there. Awesome. Okay, so this is a little bit different. You might be wondering, well, what's the difference between select, which we've been using, and select many? Well, select many flattens lists of items that are contained by other items. That is its job. So when we need to grab only the order items, and we don't want to grab all of the orders first and then grab each individual order item out of it and add it to a list, select many does all of that legwork for you. It's built to do that. So in this case, we've really actually here we may have demonstrated an example where it's a little bit more difficult to understand the method syntax than the query syntax. Here I think it's a little bit easier, especially when we know the select many operator, to do this rather than to do the two joins like we had to do up here, where we did from O in order list, from OI in order items, select OI. That's a little bit of confusing nomenclature. This makes more sense to me, especially when you understand how select many can flatten. So given the fact that now we have all the individual order items, regardless of what order they're associated with, we can roll through them and print those to the console window. Awesome. All right. So this was a whirlwind tour again of projection in LINQ. However, hopefully you can see how important this topic is. The fact that you're able to flatten, as we've just seen, hierarchical structures of data items. The fact that you can create new types on the fly using the new keyword and using the curly brace syntax to create a new anonymous type, a collection of those new types that you can then roll through only to grab the pieces of information you need for your given operation, and then let LINQ worry about how it gets that. We're just expressing intent. The fact that you can either use an anonymous type or a name type so that you can have more strongly typed and IntelliSense help and things of that nature as you're working makes this a very powerful technology. And so projection is a big topic, and hopefully you won't stop here with learning about it, but this will help demonstrate its function and its power. Go through these examples and try to pause and type in the example and see how IntelliSense helps you as you're typing these examples in. For brevity's sake, obviously had to avoid that. All right, so thank you, and we'll see you in the next video when we talk about the where clause.